Da 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 da. Gotta check my mic again. Gotta check my mic. Gotta check my mic again. Gotta check my mic. Check my mic. Check my mic. Alright, sounds fun.
Document inside the parts folder. This is a part studio. Onshape part studios are an environment where individual parts are created using various features and relationships to capture design intent. Multiple interrelated parts can be designed in the same part studio. In this tab, all the parts are highly interrelated. They have several interface points that share dimensions and bolt holes. To explore this part studio, zoom in and out using the center wheel of your mouse. Right-click and drag to rotate. Press the wheel button and drag to pan. Press F to fit the model to your screen. Use Shift-7 to reorient the model to an isometric view. These are just a few of the keyboard shortcuts. Access a full list in the Help menu. The view cube is also helpful for reorienting the model. Below it, the camera and render options contain additional tools to reorient or change the model's appearance. The bottom right contains measurement and analysis tools. Onshape uses persistent selection, so you do not need to hold Shift or Control when selecting entities to add to the current selection. Click in the white space or press the spacebar to clear the selection. In the carburetor part studio, the manifold needs a gasket to attach to the drill engine. Click the face and then click the Extrude feature on the toolbar. Extrude can use a sketch, planar face, or surface. Since the gasket's geometry matches the manifold's face, it is unnecessary to make a sketch. Onshape combines what would be several separate features in other programs. At the top of the Extrude feature, there are options for a solid, surface, or thin extrude. The solid extrude has new, add, remove, or intersect options. The feature defaults to add because we use the face of one of the existing parts as an extrude reference. Add applies the feature to the parts that appear in the merge scope. Select New to create a new part for the gasket. Set the depth to 2 millimeters. The new part appears in the parts list at the bottom left. Name the new part carburetor gasket. Assemblies are where the hierarchy and motion are defined between parts. Switch to the carburetor assembly. You can insert parts or assemblies from the same or different documents. Insert the new gasket from the carburetor part studio. Mates are how you add relationships between components of an assembly. Each type of mate in Onshape defines up to all 6 degrees of freedom between two components. Each mate is defined with mate connectors. Mate connectors are a fully defined 3D coordinate system. It has an origin, axes, and a plane on the XY. They are a powerful tool in Onshape, allowing you to define most relationships with just one mate. In the carburetor assembly, take a look at the mates that are already in place. Several components are held in place by a group. A group is not a mate, but is a quick way to lock the orientation of parts with respect to one another by their origin. It is most appropriate for parts built in the same part studio because they share the same origin. In this assembly, most parts are fastened,
My
but the
printer is
carburetor
catching
control
dust
arm
right now.
has
It
the
hasn't been
revolute
used in
made
so
with
long.
limits to show its full range of motion. Mate the gasket into place with a fastened mate. Mouse over the face and hold Shift to lock the reference. Use the hole center to place the mate connector.
Yep, remember when I was struggling with
Repeat
that?
this process for the manifold. Select the check mark to accept it. Switch to the fuel and powertrain assembly. Insert the finished carburetor assembly. Select the Assembly tab to avoid accidentally inserting the part studio. Mate the carburetor assembly into place with a fastened mate. Use flip primary axis and reorient secondary axis to get the gasket into the correct orientation.
Yeah.
By default, OnShape only moves the parts directly involved in the mate while you are in the mate dialog. Select Solve if you want to see the final orientation.
Yeah.
OnShape supplies a pre-made library of fasteners and hardware called Standard Content. Open the Insert dialog. Select the Standard Content tab.
No. Cannot do that voice.
Choose the standard, ISO, category,
Apparently they do not have
bolts
springs.
and screws, class,
Unfortunately.
socket head screws, and component, hex socket head cap screw ISO 4762. Choose the size M5 and a length of 25 millimeters. Select the two holes on the back of the manifold to place the fasteners.
Dum, dum, dum. Dum, dum, dum. Dum, dum, dum. Bum, bum, bum. Bum, bum, bum. Boom, boom, bum.
Standard content contains explicit mate
Bro,
connectors
how are they
that show
screwing
even
that in?
after
Hold
placing the
on.
part. To hide them, use the shortcut K.
Yo, what? That looks pretty easy to assemble, huh? It looks like a fun little build right there. Guess
Select
you just
the
squeeze
Bill
your
of
fingers
Materials
into there.
table tab on the right
And
side
screw it
in
in.
the fuel and powertrain assembly. It contains all the assembly instances
Yep, just
and
turn
their
your fingers
properties.
into like a bendy
In
thing.
the BOM
then.
table, you can
screw it
populate
in.
any missing properties, add in reorder columns,
I
and
mean,
export
I can see
to
that this
CSV.
comes off.
The carburetor gasket row is empty because no properties
I
are
mean,
added yet.
How the heck are
Your
you supposed
copy
to
may
screw
have
that in?
additional
It's not
missing
even
properties for fasteners
it didn't look like the
because
outside.
each company has its own instance of standard content. Edits to the properties in the
wait.
BOM are directly applied to the component's properties. Fill in the part number. If automatic part numbering is turned on, right-click and choose Generate Next Part Number. If not, type in a number. Switch to the Part Studio through the same right-click menu. Right-click the carburetor gasket in the parts list in the bottom left and select Properties. The part number is populated based on the BOM edit. This communication works both ways. Fill in the description. Return to the fuel and powertrain assembly BOM. The description updates automatically to match the part properties.
I fell asleep for a second there. But like I was saying, it would be quite difficult to assemble.
Drawings are an important part of most engineering design workflows. OnShape's drawings are always parametrically linked to the 3D models. The interface should feel familiar to other systems.
It does.
Click the Insert New tab icon at the bottom left of the document and select Create Drawing. Choose the ANSI B mm template developed by OnShape. You can make your own templates and share them for others to use within your company. See the help topic on custom drawing templates for more information.
Drawing templates.
Right-click on the tab and rename it Fuel and Powertrain. Choose the Assemblies tab and select the Fuel and Powertrain assembly. Choose the front view at 1:2 scale. Place the view by left-clicking your mouse at the location of your choice in the drawing. Move your mouse to the right and click again to place a right view. Add a bomb table. Choose a structured top-level bomb and use the bottom right anchor to attach it to the left of the title block. Add dimensions for the height and depth of the model. Add callouts for the item numbers.
Well, is she serious with that? I don't know. Personally, I just feel like I need more.
This template references
Then
the
just,
drawing properties for title
but
and
hey.
drawing number. Change it to reference the model instead. Delete the top and bottom annotations. Edit the remaining annotation and link it to the sheet reference property name. Edit the drawing number annotation and set it to the sheet reference property part number.
Wow.
After making the drawing, you may want to update the geometry.
But
Once you update the model, select the Update from this workspace icon to refresh the views in the drawing.
dun, 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 dun. I'm falling asleep. I don't know. I'm sleepy. Why am I listening to like a lullaby
Onshape's
piano?
cloud-based nature greatly simplifies sharing and collaboration. Select Share in the top right of the document. You can share with people within the organization by user or team. Link sharing is valuable when working with outside vendors. They do not need an account to access the link. This example was a document, but you can use the same share options on folders. There are a lot of tools available in Onshape for real-time collaboration. A social queue indicates there are 2 users in the document. You can simulate this by duplicating your browser tab. If you mouse over the social queue, it tells you who is in the document. Social queues also show you what tab and feature they are in. Every change is immediately available to everyone in the document. Double-click the social queue in the top right to enter follow mode. You can see the other person's current view of the model, cursor movements, selections, and feature dialogues. This is helpful when communicating over the phone to show someone else a specific aspect of the model. Additionally, comments are another critical tool for collaboration.
For collaboration.
Add a comment to the document.
Your gasket is
You
absolutely
can tag other
dastardly.
users in a comment by
And it's
using
trash.
the @ symbol.
Wow. Well, I have no one
When
to
you have tagged
collaborate
someone,
with, so
there is an additional option
I
to
could probably
assign
take a
an
little
action
nap through
item to them.
these.
You can add a markup to the comment to clarify your
We're about to
request.
collaborate with himself.
Start the markup tool. Add an arrow to the gasket. Denote that it should be 1 millimeter thick. Once you accept the markup, it attaches as an image on the comment.
Really? And next lesson.
Every change in a document is recorded in the Versions and History panel. The action, user, date, and time are captured. Any point in history can be restored. The in-progress version is called the workspace and is indicated with an open circle. You can create a named version to define a milestone in the history of the document. This creates a reference point that is easy to access at any time. Create a new version named Fuel and Powertrain Complete. The Versions and History panel also contains tools to create branches. Branching allows you to create multiple workspaces.
Create a new
Each
timeline.
workspace is independent, allowing you to create variants or test design
See,
changes.
she said variants.
Carrying them over to the main workspace. To create a branch, you need a named version. Right-click on the named version you just created and choose Branch to create workspace. Name it Alternate Gasket Thickness. In the new branch, edit the carburetor gasket extrude and change it to 1 millimeter. In the main branch, the gasket remains 2 millimeters thick. To copy changes from one branch to another, make sure the destination workspace is active and right-click on the source workspace. Choose Merge into Current Workspace. The tabs that have changes show at the top. In this case, the Part Studio and Assemblies the carburetor gasket is in show as modified. The default is to replace the tab with the branch, but you could choose to keep the main branch tab instead in certain circumstances. Replace the tabs in the main branch and select the Merge button. Now, the main branch also reflects the 1 millimeter gasket thickness. There is also an action recorded in the history. If you need to undo the merge, right-click on the action before the merge and restore to main.
Next lesson.
Release management is available to professional or enterprise level subscriptions. If you do not have release management turned on for your company, you may not be able to follow along with this video. Release management is a formal revision and approval management system that controls individual items within a document, such as parts, assemblies, drawings, and imported files. Insert a revision table on the fuel and powertrain drawing. Fill in the revision description as initial release. Right-click on the Drawing tab and choose Release to create a release candidate. A release candidate is a container for all the items moving through the release workflow. The release candidate automatically adds all the drawings references. Every item that goes through release management must have a unique part number. Click the Generate Missing Part Numbers icon in the part number header of the dialog to generate any missing numbers. If you do not have automatic numbering enabled, manually populate any missing numbers. Fill in Initial Release for the release name and release notes. You can select Release to release without approval or select an approver. then click Submit to send it for review. If you submit the release candidate to an approver, they will receive an in-app notification and an email. The Versions and History panel shows the outline of a triangle for the appropriate version, indicating it has not yet been approved. Once it is approved, the released version shows in the Versions and History panel as a solid triangle. If you open the released version, the drawing is updated with the approver's name and approved date. If you released it yourself, your name is entered as the approver.
Oh, fell asleep, and now I'm back again. I have no idea. Only one short of completion. I'm about done with everything. Almost there at the ending. Hit me. I'm so freaking tired. It's just me. And I cannot get sleep on. Was that a question? Like, I'm so sleepy, bro. I'm literally falling asleep at the computer. I don't even know what's happened. Half of this I just knocked. Definitely need this.
Curves are one-dimensional entities such as splines, conics, lines, or arcs in a 2D sketch, or one-dimensional entities in 3D space such as helices, bridging curves, or 3D fit splines. These entities are typically used to create a framework for advanced part modeling and surface design. Curves are the underlying geometry that defines surfaces or complex solids, where the curvature and smoothness of the resulting geometry is critical to the design. This course focuses on establishing the needed framework for a complex model by understanding how to use curves, including conics, splines, and helices. When working with complex curves, especially different types of splines, it is important to understand how to evaluate the quality of the curve. A high-quality curve defines a high-quality surface. Splines are piecewise polynomial curves, where the curvature can change along its length. Curvature is the inverse of the radius of the curve, and can be visualized with curvature combs. To access curvature combs, select the entities, right-click, and choose Show Curvature. Shift-C also shows curvature combs for all entities within a sketch. The combs display perpendicular to the curve, and the length of the comb increases proportionally to the increase in the curvature of the curve. Use the slider in the dialog to adjust the size of the combs. To display the minimum radius of a curve, check the option Minimum Radius. The combs are longest where the radius of the curve is the smallest. The display of curvature combs persists while adding dimensions and relations to sketch entities. This is helpful when evaluating the quality of a spline or curve. If Show Curvature is disabled, re-enabling it maintains the previous selection of entities. When you evaluate a spline, you typically look for smooth transitions between the combs. Too many spline points can cause a rapid change in the curvature and create a lower quality spline. Less is more when defining splines. Try to control a spline with a minimum number of spline points.
I did not know
When
that.
displaying curvature combs, you may also display inflection points, which is meaningful when the curves are planar. Inflection points appear where the curvature changes directions, displayed as a bow tie in the graphics area when the option is checked. Understanding the relationship between two curves is another important aspect of evaluating curves in a design. Continuity describes how two curves and resulting surfaces defined by those curves flow into one another. There are different types of continuity referred to as discontinuous, G0, G1, G2, and G3.
This is the stuff in CAD.
Discontinuous curves do not share an endpoint and do not have a G value. G0 describes curves that only match in position, basically only sharing an endpoint. The curvature combs resulting from two curves that meet with G0 continuity display different lengths without any smooth transition, and may even crisscross over each other. G1 describes continuity between two curves that share position and tangency. These curvature combs are parallel to each other, but there might be a jump in curvature if the curvatures do not match. G2 continuity indicates the curves match in position, tangency, and curvature. The curvature combs between two curves that are G2 continuous are parallel and have the same radius at the point where the two curves meet. Curves that are G3 continuous match in position, tangency, curvature, and rate and change of the curvature. G0, G1, and G2 continuity can be established between entities with constraints and dialog inputs in Onshape. G3 continuous curves cannot be created automatically in Onshape, but may be manually created by matching the curvature combs with construction geometry and relations.
So let me get that straight. Ow, just right over my foot. That hurt a lot. So G3, curves that are continuous match in position, tangency, curvature, and rate of change of the curvature. Okay.
A conic is simply a curve that results from the intersection of a cone with a plane. There are four main types of conic selections: hyperbola, parabola, circle, and ellipse. An ellipse is a closed curve created by the intersection of a cone and a plane. A circle is a type of ellipse created by a plane slicing a cone perpendicular to the cone's axis with the minor and major axes equal. Creating circles and ellipses in Onshape sketches is explained in the Fundamentals Sketching course. A parabola or hyperbola is an open curve created when the cutting plane intersects the cone. Conics have a virtual sharp, which is an intersection point of the tangents to the conic arc and its endpoints. The point closest to the virtual sharp on the curve is called the vertex of the conic. Onshape controls the shape of a conic by a value called rho. Rho is the ratio between the distance along the line connecting the virtual sharp and the vertex of the conic. We will learn how to create a conic in a
See,
sketch
that's
in the
why
next
when I
video.
tried to put a higher number on it, it wouldn't work because it's a ratio. So it shouldn't be greater than, what, 1? Or it shouldn't even be 1?
To create a conic, edit a 2D sketch or create
So
a
I was
new
trying to make
sketch.
the gear.
Select the conic sketch tool from the sketch toolbar.
That did not
By
work.
default, this tool is located with the arc sketch tools. The first click is one of the endpoints of the conic. The second is the other endpoint. The third click defines the virtual sharp of the conic. Lastly, input the row dimension. After creating the conic, the virtual sharp may be repositioned or aligned to other geometry in the sketch with sketch constraints or dimensions. The arc length of the conic may also be defined with the dimension tool. A dimension or sketch relation may be added between the endpoints of the conic as well. The row dimension defines the ratio between the distance along the line connecting the virtual sharp and the vertex of the conic. An additional dimension is not needed and cannot be added. After defining the conic, it can then be used to create geometry as a sketch profile, a path for a sweep feature, or as a guide or path to define lofts or surfaces.
I got distracted for a second there.
Or as a guide in the conic. A row dimension defines the ratio between the distance along the line connecting the virtual sharp and the vertex of the conic. An additional dimension is not needed and cannot be added. After defining the conic, it can then be used to create geometry as a sketch profile, a path for a sweep feature, or as a guide or path to define lofts or surfaces.
Alright, hold on. No. Bring me back. Yeah, I'm really not paying full attention, which is bad. Alright, let's...
After defining the conic, it can then be used to create geometry
So he used the conic there.
as a sketch profile, a path for a sweep feature, or as a guide or path
He used it there. Okay.
to define lofts or surfaces.
Fair enough. I now understand. We're starting from scratch, huh? I close, close, close. It doesn't make sense I edit these. Alright. Exercise export. Let's delete this. The wheel. Bye bye. Yeah, sure. Let's make a new part. Go to the top. Alrighty. Let's sketch. Yep. Alright, top plane. 3 by 6. That's G. Hit D. Make this 3. Make this. Control A. 6. Ooh, center point rectangle. I did not know that. Yeah, let me begin that. So let's press QL. If I want it to be 3, then this should be Should have been holding it. Now hit D. Half of 3 is going to be 1.5. Then hit E. This one and this one. Then hit Q. Release E. Hit Q again. Turn it to construction line. This on this. I. Looks like it did some auto constraints, so I don't need to do that one. Alright, now line Q. This one, half of 6 is 3. Escape. What the heck is this? Okay, select this, this, I. Can't go anywhere there, can't go anywhere there, can't go anywhere there, can't go anywhere there. Alright, D. Make this exactly 3. E is up and down. Alright. Now escape. I'm gonna put this on this with a midpoint constraint. What's that? Shift M? Okay. Midpoint. Alrighty. That isn't gonna move anywhere. Cool. Alrighty. Could have done it with less, but I made a mistake, so rename sketch top profile. Oh. Why'd you make... Okay. Get back into it. Conic. Make sure both endpoints are coincident to the corresponding sides. Alrighty. Here comes the conic. If I can remember where it is. Conic, conic. The chronic. Want to be, oh wait, 0.75, and then I want these to be, what was it again? Oh crap, this is 0.75. This is 0.5. And then this is 0.75. There we go. There we go. I mean, I feel like it's good, but oh crap, don't want that. There's my phone falling once more. Hit this with a tangent, even though it's unnecessary. Hit this. Okay. Yeah. Alright, there we go. pinpoint instead of each line. Okay. Select. So. Alright. Hit this. Mirror. Mirror line. Center line. Yeah, I remember that from FreeCAD. Yeah. Okay. Makes sense. Alright. Now, let's go again. Did it do it? No, it didn't. Escape. Select a mirror line. Oh, shit. Well, this works. Entities to be mirrored. This and this. There we go. Alright. Yeah, press escape to stop the mirror. Yep. Trim the sharps of the rectangle as shown. Bro, what? As shown? You want me to just delete the rectangle? I don't see a trim option. I know they, oh, yep, I see. What just happened? Oh, because that's that endpoint. No worries. Let's hit, is it D? No, that's tangent. Trim is M. Okay. Get rid of this. Get rid of this. 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 Not sure how that's still there, but okay. Let's center it back up. It appears to be constrained again. Okay. That's still good. Put another dimensioner off of these guys. I mean, I know it's 3. It knows it's 3. Just reminding it. Create an offset plane off the top feature. So gotta exit out of Sketch. Pretty sure you can't use that while in Sketch. Top profile. Let's do offset. Where is that? Cutlass frame. Oh, offset surface. Alright. Define so that the new plane is below the top plane. Alrighty, so if it's approaching us at the top, then we want to flip it, and we want to get rid of that too. Now it's offset to the bottom. get into the habit of naming everything. Click online. Disappear. Alrighty, click on the line. Then sketch profile. Create selection. Alright, so create a new sketch on the bottom plane. Rename the sketch bottom profile. To create a bottom profile, we must offset the first sketch. To quickly select all entities, use the Create Selection tool. Right click and choose Create Selection. In the dialog, click Edges and then choose Tangent Connected in the pull down. Click on the line of the top profile sketch and then click Add Section to pre-select all needed entities. So this is the top profile. This is a little bit confusing, but okay. Sketch, and then we want to go so we want to name this bottom profile. And then we want to right click. So let's show this again. Shift Y. All right. Right click and choose Create Selection tool. Tangent Connected Selection. So let me selection. How do I get rid of this again? Ah, crap. Hide. Hide, hide. Forgot how you move all of these out of the way. Huh. Let me change the appearance of this. Did I need to make this into something? Nope, I don't. So bottom profile. in the bottom profile. Alright, that's that. Now you come in here and rate selection. Yo, to these two. Bro, unselect this. This is definitely gonna mess this up. Please leave. Damn. Alright, let's try that again. Create selection. Select patterns. Let's do it manually, because for whatever reason I can't get rid of that one. Not sure why it's so obsessed with that construction line. Yeah, that's it. Alright. And the dialogue. Click, yep. Tangent. Click on the line. Top profile sketch. What? Click on the line of the top profile sketch and then click add selection to pre-select all needed entities. Alright. With all edges of the top profile, so, alright. Inwards. So we use an offset. That's out. We want to flip that. Negative. 0, 1. Yeah. Did it do it properly? Looks like it. Mine's just in a different place. Yeah. Escape. What? Oh, because I moved it? It didn't know what I was defining anymore. Okay, I'll leave it there. It's fine with me. Alright, select loft. Alright. Bottom to top. Done. Bottom profile. Top profile. Alrighty. Now, where's loft? Right here. Profiles. Bottom profile. And then top profile. Yeah. That's how they did it. Okay. I'm gonna name it plate. Done. To create a bevel detail, create a new sketch on the plate front place. On the front plane, bruh. Front plane, new sketch. Front plane. Yep, definitely centered in the plane. Next. Pierce the endpoint at the end of each line to the edge of a part. Okay. What do you guys have it upside down doing that? Anyway, I shall flip. Alright, line and then press Q. That's one. Done. No. Where is the pierce? Okay, so let's do a U. Bring this here and make it horizontally locked. Okay. How about this then? There you go. Now this and this hit this. Bro, what the hell? Intersects the sketch plane. Pierce. Alright. That's cool. I am not getting it. Pierce the end point of each line to the edge of the part. Do these need to be brought in order for me to do that? U. Sh. G. Was it applied? probably selecting this edge, but I need to select this edge. So that works? Okay. Same here. Alrighty. Interesting. Alright. Now from there, alright, so let's make a conic. Do 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 do. .6.25. And good measure, let's make everything tangent like the tutorial says to. T. No. Well, doesn't even make any damn sense. What? Why is there two of them? There's one here. Should I really make one here? That doesn't... Yeah. What? Huh, that's funny. What if I put it here? It spins me around this. So I guess it... Alright. See a way to look at it? Alright, so like as shown, the vertex is coincident to the top construction line. Alright, and one endpoint is coincident to the endpoint of that construction line at a tangent that constrains between the conic and the construction line and the conic and between the conic and the top edge of the part. Okay. So here and here. And make that another tangent right there. Alright. There's that there, that there, that there. And they also want me to make this coincident. There you go. Like after all of those constraints, it's still not grayed out. Just a nice reminder of how fun it is to do this, try to constrain this stuff. Those to the bottom endpoint is coincident to the endpoint. Alright, the endpoint is coincident to the endpoint of the first conic. Define it as that at a tangent between the conic, the construction line, and the conic and the bottom edge. I think I might have made my thing upside down, but it's fine. So what is that again? Okay, 0.375. Three. Alrighty. And they want me to make tangent construction and the bottom edge. Okay. Escape here, this and this, tangent, and then this and this and this, tangent. Alright. Let's try that again. There we go. Alright. Oh, they also want me to the whose vertex is coincident to the bottom. So we need this to be coincident to this. So this construction line, yeah. All right, maybe I won't make it as construction line then. Alrighty. Selected face, and then sweep profile. Alrighty, so done with this. Select face, sweep. Path, most likely right here, but I'll let them tell me. To create a closed profile, select the intersection sketch tool and click on the face side of the part. Bro, what? Intersection. Hold on there. Yeah, okay, they probably got rid of the intersection, just turned it into sweep because it looks like a sweep to me. So, yeah, anyway, sweep path is right there. Alright, let's add dimensions. Let's close that for now. .375. that to that. Zero point 125. Did I miss something here? Oh, now it's here? Are you serious? Alright, let me close my sketch. Search tools. What? Does it only show up when I'm in there? Wow. Oh my goodness. Let's stop this tool. Oh, now it's here. Oh, that's it. So, select that. Hit this tool and then select this plane. Oh, that's how that was made. I just lost my dog. Alright, there we go. That's a lot better. Now let's use it once more. There we go. To turn off the tool, escape. Now the constraints are gone again. So let's add them back. D from here to here. Point 125. I just lost my dog. Oh, that's why I'm bored. There's no music again. Didn't I already play this? Oh, I did. Alrighty. Nope. 0.0 325. Nope, 75. I bet it's not right. Oh wait, it might just be. Should I make these two tangent with each other? Oh, okay. Done. I did sweep. So let's see profile sketch as. Alright, select sweep in the feature toolbar, choose a solid, add options. What? Be sure the plate is chosen in the merge scope. God, where's the merge scope? Select the swap profile sketch. Oh my gosh, I'm getting fried. I might be getting tired. Alright, bro, let's just see if I can figure this out. Faces and sketch. Alright, this is the face. This is the back. No. This is the back. Looks like it's working. What was this thing telling me to do? Solid, it's an add. Merge scope. Part 1? Oh, I never renamed it. Yeah. Alright, well. Merge scope, yeah, plate. Create selection tool. All edges. Selection, edge of log. Okay. What did I do? I think I just selected the sketch and it worked too. Bases to remove. So we sweep. Alright. Alright. Sweep it. And then now shell the part. So we're shell. Is this not a face here? Let me get out of this. Alright. I'm doing this whole damn thing upside down, huh? What the hell is wrong with me? Alright. So let me do shell. is this here if it doesn't exist? What is that? Delete part? Hollow. Thickness is gonna be 0, 25, 25. Guys are still here. Across. What the hell? Okay. I'm surprised. Why is it still here? Why is this thing here? What is this? The bottom profile. Okay. Make it invisible. Why is it still there? What the hell? Alright. So what did I just show? Okay, so alright, let's try this shell again. Delete. Let's do another shell off of this. Hollow. This non-existent face. Oh my goodness. How the hell do I end up here? You know, I don't know. I don't know. What can you do? Somewhere I missed it. Somehow, I don't know. Fair enough. Do it. Now, for some reason, this is still here. Face of law. I go into this. Parts to hollow. Face to remove. Oh, you don't actually select hollow. Oh my goodness. Oh. Yeah. Wow. Well, I figured it out. Little, pool. Alright, surface area. Yeah, my surface area. I know. What material you want me to make it? Oh, wait, surface area does not matter. Bro, I keep messing up. This is bad. I'm sorry, not quite. What did I do wrong? Hold on. Let's... Okay, so... Should I just do the shell? I didn't even read. Surface area of the plate. No. Let's see what they tell me to Select the plate from the yep, and then yeah, okay. So something is wrong. Something is wrong. Why is there a revolve in here? Bro, what the hell? Is that still part of part one? Let's delete the revolve. Delete the sketch. Delete this part. Surfaces. The hell is that from? Oh, okay. Okay. Let's see if that's better. It didn't change. Alright. As you can see, mine is definitely none of these numbers. So I'm gonna have to do this again. Alright, well, I'm gonna take a break. Anyway, it's been an hour and 32 minutes. I've been sleeping, waking up, doing all kinds of madness. Chloe quits. Well, I already took my out.